Hello, dear students. Welcome to the world of nuclear technology, scientific breakthroughs, and sustainable development. My name is Maria Tserina, and I'm a leading specialist at the Mathematical Modeling and Digitalization Department of Prarif JSC. The Prarif, or Breakthrough Project, creates the future of nuclear energy. And that's what we are going to talk about today. I will also tell you how to look into that future. No, not with magic crystal balls or spells, but through science and technologies. But before we travel into the future, let's look at the present. What nuclear energy looks like today. Modern nuclear power plants provide humanity with clean, stable, and affordable energy. Nuclear energy doesn't depend on the weather, it operates in various climatic conditions. One of its main advantages is the enormous energy density of fuel. Just imagine 1 gram of uranium gives as much energy as about 2.5 tons of coal. During operation, a nuclear power plant does not emit greenhouse gases into the atmosphere, and over its entire life cycle, from uranium mining to waste disposal, a nuclear power plant's CO2 emissions are lower than from solar panels or wind turbines. But even such significant advantages over other energy sources do not mean that nuclear energy should rest on its laurels. On the contrary, its huge potential requires constant progress. Today, the industry faces a few natural barriers that it must overcome on its path to a bright future. The reserves of natural uranium 235, which fuels thermal reactors, are not infinite. According to various estimates, it will last for 60 to 150 years at current consumption levels. Therefore, we need to find a way to expand the resource base, for example, to use the much more common but less active isotope uranium 238 as a fuel. The Prairie Project is the answer to these challenges. Its goal is to create a new generation of nuclear energy based on the principles of inherent safety and competitiveness. The main idea is a closed nuclear fuel cycle with fast neutron reactors. More than 2,000 specialists from over 60 organizations are working on the Prairie Project. The project is currently in the active implementation stage. In Severs, Tomsk region, a pilot demonstration energy complex is being built. This complex will demonstrate the closure of the nuclear fuel cycle. Now, let's pause for a moment and talk about nuclear fuel cycles. There are two types of such cycles, open and closed. The auto arc in the diagram shows the open nuclear fuel cycle, the traditional chain from uranium mining to spent fuel storage. The inner circle with green arrows shows the closure of the fuel cycle. Unlike the open cycle, here spent nuclear fuel is not sent for long-term disposal, but is reprocessed to extract valuable fissile materials, which are then reused to produce new nuclear fuel. Radioactive waste is minimized and the resource base becomes almost limitless. Fast neutron reactors can produce new fuel not only for themselves, but, if necessary, also for thermal reactors, and can also burn uranium from spent fuel left by their thermal elder process. This is called a dual-component nuclear power system. The closed nuclear fuel cycle has many advantages. First, it's a new level of safety. The very design of fast neutron reactors reduces the risk of accident to a record low. Second, it provides technological support for the nuclear non-proliferation regime. Third, it makes full use of the energy potential of uranium, and it's economically feasible. A closed cycle makes nuclear energy truly sustainable and virtually waste-free. This is not science fiction. It's an engineering reality that the Prarif project is creating today. At the very beginning, I promised to tell you how to look into the future. And now we come to the most interesting part. How can we be sure that a complex technological system will operate reliably and securely even before its actual launch? How can we see a potential problem long before it might occur? The answer is digital twins. A digital twin is not just a beautiful three-dimensional model. It is a virtual representation of a real-world object, system, or process. Digital twin is updated with real-time data, which can be used for machine learning and reasoning to make better decisions. We can study all sorts of potential situations, analyze performance problems, and create potential enhancements that can be used to improve the real physical object. Digital twins are designed around a two-way flow of information that occurs when the object sensors provide relevant data to the digital twin, and then that happens again when the insights created by the digital twin are shared back with the original source object. And since digital twins are meant to mirror a product's entire life cycle, it's not surprising that digital twins have become widely used in all stages of manufacturing, getting product from the design stage to the finished product and all the steps in between. Prarif is using digital twins to look into the project's future. Now, let's take a look at it. This is the pilot demonstration energy complex. It consists of three main parts. The first is the spent fuel reprocessing module. The second is the fabrication refabrication module, where fresh fuel is made from reprocessed materials. And the heart of the complex is the reactor unit called REST. This is a fast neutron reactor with lead coolant, one of the safest and most promising in the world. All parts of the complex operate together on the same site for the first time in history. The digital twin of the pilot demonstration energy complex consists of databases, computer, mathematical, and simulation models, as well as design documentation, requirements, and real-time data. Since the digital twin evolves in parallel with the physical object, the fabrication refabrication module currently demonstrates the highest level of maturity among all components of the digital twin. By the time the construction of the complex is completed and the power unit produces its first portion of energy, its digital twin will have already prevented equipment failures, saved millions of dollars, and become a new global standard. The Prairie project is not just a step forward, it's a leap into a new era of nuclear energy. Safe, efficient, and virtually waste-free. Thank you for your kind attention.